Soon, IXV, Europe's intermediate experimental vehicle, will be launched into space on a Vega launcher from Europe's spaceport in Kourou. The mission wants to test new aerodynamic solutions, innovative structures and materials, advanced guidance navigation and control laws, and understand how they behave under the very harsh conditions of atmospheric re-entry.
IXV is a technological re-entry demonstrator whose purpose is to experiment the technologies associated to the atmosphere re-entry.
Mastering re-entry technologies is key for Europe's ambition to return spacecraft autonomously from space.
Atmospheric re-entry is certainly a cornerstone for a variety of space applications, and these go from, of course, in-orbit servicing of orbital platforms like space stations and so on, as well as robotic exploration and returning a sample from other planets for planetary missions.
In the autumn, Vega will launch IXV into a suborbital path. After separation, IXV will fly over the Earth to reach the re-entry point and begin validating critical atmospheric re-entry technologies. The first objective is to measure, with the help of more than 300 pressure and temperature sensors, all the phenomenon that will allow us to validate the aerothermodynamical behavior of the vehicle in hypersonic flight. The second objective is to validate the in-flight performance of all the advanced thermal protections used, which are ceramic and ablative materials. A third objective is to prove the guidance, navigation and control systems which will guide the vehicle as it travels through space. A trip that should be eased by IXV's aerodynamical body shape.
It has the simplicity of a capsule without having the disadvantages and having the performances close to those of a winged vehicle, so having the capability of maneuver, control and precision landing.
Well into its final integration phase, here in the Thales Alenia space premises in Turin, the IXV is getting progressively dressed up and its systems thoroughly checked. In the Mission Control Center, technicians are rehearsing the data transmission choreography that will take place on launch day.
The day of the mission, the vehicle will be passing over the various ground stations and during those minutes send back the data here. So we are simulating this by means of data that have been recorded from the real vehicle, and they are replayed at the various ground stations and sent here in the same way that it will happen during the day of the mission.
After splashdown, IXV will be recovered by a ship and taken to the lab for post-flight analysis. Understanding how it feels to navigate through our atmosphere exposed to extreme temperatures will take Europe one step closer to future space missions, requiring autonomous controlled re-entry to Earth.